Okay, in the question on the review here, we have some grams that are put into the 10-liter container at that temperature and asks for what's the initial molar concentration. So that part's pretty simple. You're just going to take the grams and divide it by the moles. Grams and go to moles, and then divide those moles by the liters. Okay, so that part's pretty simple. Then it says, what's the initial pressure of it? Well, if we have the volume and the temperature and the moles, so we can find the pressure because of PV equals nRT. So we can substitute into PV equals nRT, and we're going to find that if we use 0.0821, we have 0.969 atmospheres. So that part's pretty straightforward. And part B, it says that it decomposes according to the following equation. And what's the equilibrium constant expression? So that's, again, products over reactants. I haven't had anything really challenging yet. And then it says when it's decomposed, 27.7% of the original moles has, let me pull this over. Has decomposed, calculate the concentration. So this part's a little bit confusing because we have to take the moles that we started with and then we need to figure out how much of that is left. So if we lost 27%, then we're going to have 72 will be the AS, or about 72 will be the AS F5. So we'll take 72 times the initial molarity to find the new equilibrium molarity. Okay, once you have that equilibrium molarity, we can calculate the value of the KEQ. So we use the products over reactants. And these are all to the first power because the coefficients in front are just 1. And we know that this one we just calculated was, the one that we just calculated was 0.0226. And the other ones will be like 0.27 times the initial molarity, which was 0.0313. Okay, to get those numbers that go there. So that's going to be 0.00867 for both of them. Okay, so when you do that, you can find the KEQ, which is 0.0033 equals KEQ. This is II. And then the last question that we are asked is, so this one was kind of hard because you just had to figure out where part was the 27 and which part went with the 72. And then the last question that we have in letter D is the mole fraction of the F2 in the container. So all you need to do to find the mole fraction is the total moles goes on bottom and the moles of F2 goes on top. And we can actually just use the molarities here because the liters part will cancel out in the division. So we have 0.00867 plus 0.00867 plus 0.0226, and the part that's F2 is just 0.00867. And when you do that, you'll find that it's about 0.217.